Hey everybody, welcome to today's webinar. We're going to give a few minutes just to let people trickle in, but we'll get started here in 30 seconds and look forward to passing along Amazon Aurora Cloud Databases 101. All right, welcome to today's webinar, Amazon Aurora Cloud Databases 101. I am Jay Martin, your host for the next half hour. This webinar will very much be driven by your questions, so please add them to the Q&A section on the right side of your screen throughout today's presentation, and our exclusive Aurora expert will do their best to answer each of them before we wrap up. Before we get too far along, I'd like to introduce you to the brains of the operation here, Mr. Craig Nelson, one of our fine solutions architects at ClearScale. Craig, if you'd be so kind to give a nice introduction to ClearScale as a company, as well as a quick overview of your role at ClearScale.
Sure. So hey everybody, my name is Craig Nelson. I'm a solutions architect here at ClearScale. ClearScale is a premier consulting partner with AWS, which puts us in the top 3% of all partners in the AWS ecosystem. Our services range from architecture design, cloud migration, application design, all the way to support and managed services. We were recently awarded our 10th competency, which is something we're reasonably proud of. Naturally, if you're not aware, the AWS competency program is designed to identify and validate partners who have just demonstrated AWS technical expertise and given proven success in a given area, which is really like a long-winded way of saying that we've spent a lot of time developing expertise in those areas listed in that table there on the right. This cover areas such as data analytics, migrations, DevOps, to more vertical specific topics like healthcare, education, nonprofits, and so on. As far as our team goes, the vast majority of our staff is highly technical in nature. We're actually closing in on completing our 1,000th project with AWS, so that's kind of a big number. We like to say we were born in the cloud. Our focus is and always has been 100% AWS, so we don't spend any time on the other cloud providers, which really ensures that we're able to move in lockstep with AWS at all times as their services evolve. There down below, we've recently received a badge showing that we are now part of the AWS 100 Certified Partner Network, which means that we have 100 team members who are AWS certified, which really just means that we have the expertise and experience to make your AWS cloud initiative successful, really no matter how complex your needs are.
Perfect. Well, today we have a three-pronged approach to the webinar where we're going to start with Craig discussing what exactly Amazon Aurora is and why companies choose to utilize it. And then we'll take a look at a pair of real-world examples, how it was implemented, what it solved, and more. And finally, the floor is yours. We want to answer all of your questions. So again, please fill up that Q&A section and we'll cover everything we can. All right, well, let's get started. Craig, if you would please take us through what exactly is Amazon Aurora?
All right, so what is Amazon Aurora? Well, it's Amazon's version of MySQL and Postgres. It sort of has this dichotomy where it can play either role. You can act like Postgres and it can also act like MySQL. It's really just a relational database managed by AWS. It gives you the security, availability, and reliability of a commercial database at a fraction of the cost. It has a lot of really cool features that are mentioned here in this slide, but we're going to get into all these in a bunch of detail here in just a minute in the upcoming slides. But Amazon Aurora is a really cool tool. Excited to tell you guys about it. So what are some use cases for Aurora? Well, we got three listed here. Your enterprise applications or SaaS applications or web and mobile gaming. But really, anywhere you're looking for a relational database and don't want the hassle of managing or administering a relational database is going to be a good fit for Aurora. NoSQL is a real popular topic for applications, but the truth is the death of relational databases has been greatly exaggerated. And it's worth pointing out that Aurora and more generally Amazon RDS it's not a panacea. I mean, DBAs and things like that are still needed. But by using these services, these managed services from Amazon, you can focus on more administrative tasks like or operational tasks like tuning parameter groups or query tuning, as opposed to making sure that your backups ran or making sure that your hardware is tuned or your data is structured correctly on the disk. Really gets you focused on more value-added tasks as opposed to low-level administrative tasks. So let's get into the meat of this thing. First off, we have the MySQL compatibility. So what does that even mean? Well, what it means is that your code and your applications, your drivers, all the tools that you use today can be used with Aurora with little or no change. The most significant differences are at the storage layer, and really they're transparent to users and applications, which means that if you were to migrate to Aurora MySQL off your existing MySQL implementation, you're not going to have any hiccups. It's really going to go rather smoothly because it's essentially the same database, at least at the surface. Amazon claims to get 5x performance over vanilla MySQL. So how do they do that? Well, the truth is it's not actually MySQL, it's MySQL compatible. Amazon has optimized it significantly, and a lot of those performance gains are due to that, how that storage is structured behind the scenes, like I mentioned. How they get there isn't so important as the fact that they did get there. So there's a couple features I'd like to talk about, and these aren't necessarily specific for MySQL. They're Aurora specific, but MySQL and Postgres share a lot of the same features with Aurora under the covers, but let's get into them. First up, we have push button compute scaling. So with Aurora, you do have to provision the compute power when you spin up the database initially, but you're not locked into that amount of horsepower like you would be if you had an on-prem database. With Aurora, you provision for what you need now, as opposed to buying hardware for your data center, where you need to, buy for the future to ensure you have the necessary capacity. Since scaling in the data center is just about impossible, at least not without spending a bunch of money and time. With Aurora, you can increase or decrease that provision compute power at any time. You do have to take an outage to do so, but the fact that you can do so is what makes it noteworthy. If your demand drops, you can scale down, only pay for the amount of compute you actually need, or same thing if you anticipate a spike in demand, you can add more compute power, and as opposed to on-prem where you have to design for your peak load, and you spend most of your time with underutilized hardware. So that's essentially a waste of money for that 1 or 2 weeks where you actually need to have that peak hardware. Next up, we have the multi-AZ deployments with Aurora replicas. So Aurora stores your data across 3 availability zones. So even like a significant disaster is not going to impact your operations or result in a loss of data. They claim if you lose in that availability zone, there's not even a degradation in performance. So that's a really cool feature. Second up, if your application is read heavy, Aurora allows you for up to 15 read replicas across multiple availability zones. And you can add these whenever, and you can scale the compute power behind them independently of the master node. So if you decide that you've got a ton of read traffic and it's really impacting the performance of the application, you can spin up these read replicas and revert or divert all the traffic there through a separate load balance endpoint. Really make it easy for applications to accommodate that reader functionality and take the load off the the writer side of the database, so your users aren't necessarily impacted. Another cool thing is in the event of an outage, that read replica will automatically be upgraded to the primary database. So there's no need to recover from a backup and deal with downtime and lost transactions and all that stuff. Now, I do want to raise an important point that if you're comparing or if you're familiar with RDS, RDS also offers read replicas and multi-AZ deployments, but read replicas in RDS can't automatically be upgraded to the primary in the event of an outage. You actually have to take action to do that. Whereas with Aurora, that read replica can automatically become your primary. And then as far as multi-AZ goes, you can't read from the multi-AZ replicas. So really there's RDS sort of solves this problem with 2 approaches, but they don't necessarily work in concert with each other very well. Whereas with Aurora, it really takes the best of both those features and merges it into a much more convenient service offering. And then if you really need to push the limits, Aurora supports multi-master configuration where you can have multiple nodes handling the database read and write traffic simultaneously. If you ever tried to do that on any other database, you'll find that it's challenging or super expensive. I don't want to name any names, but a tool called Golden Gate comes to mind. They're really expensive to do these sorts of things, and Aurora gives it to you essentially out of the box. So next up, we have advanced auditing. So Aurora offers some optional fine-grained auditing, which sends logs right into CloudWatch. You have a la carte audit selections for DML operations, DDL operations, logging specific users, etc. You can pick and choose what you want to audit. The logging payloads themselves are detailed to allow for complex analysis. You get down to the operation, the database object that was involved, the user, the timestamp, all sorts of good stuff. And of course, all that goes right into CloudWatch, or I guess you could divert it to Elasticsearch for all your analysis and amusement needs. Next up, we got automatic software patching. So Aurora, as with all RDS actually, Amazon manages all the hardware and software patching for you, so you don't have to even worry about it. Patches happen in a defined 30-minute maintenance window, and the database is usually only unavailable if the actual updates require an outage restart, which is somewhat rare. It's worth pointing out that performance could be minimally impacted during that maintenance window, but the truth is, when that maintenance window is coming, and you can actually schedule it when you spin up your database, or I guess you can move the maintenance window after the fact. But Amazon takes care of all that for you, so that's really nice. And then the last bullet point there is you pay only for what you use. Like all RDS databases in Amazon, you only pay for the provisioned compute. You can change that amount of compute provision at any time. Of course, you do have to take an outage, as we mentioned. But the storage charges themselves are about $0.10 per month, or $0.10 per gigabyte per month, I should say. $0.10 per month would be fantastic. Everyone should get on board. But it's actually $0.10 per gig per month, which is still pretty good. But the nice thing is that you don't have to worry about buying a shiny new storage array for $1 million that's sized for your expected growth as opposed to maybe what you need right now. Aurora automatically scales your storage as your needs increase, and scales it back down for you if you purge off data. That's actually a recent feature that was added. It used to be that if you dropped a couple tables, you didn't reclaim that storage, you had to take some action to get that storage back. Well, now it scales up and down with you automatically. So really, they've taken a lot of the administrative load and put it on themselves and taken it off you so you can focus on your business and spend less time worrying about how to administer a database, because that's probably not what your business is. Now, looking at Postgres compatibility, again, the Aurora supports MySQL and Postgres compatibility, so you can pick your which flavor of the database you want when you spin it up. Of course, once you spin it up, you're sort of stuck with that. If you decided you'd rather have MySQL, then you may have some work to do. But from Postgres compatibility standpoint, it's the same thing as MySQL, which means that your code, application drivers, and all that you can work with Aurora Postgres with basically no change. Again, those differences are at the storage layer, and that's how they account for that 3x performance. If you're like me, you're asking why 3x and not 5x if they got 5x on MySQL, but I guess that means either Postgres was already really tuned or there's more performance to be squeezed out of this thing at a later date. I guess Amazon will have to tell us that at the appropriate time. But in the meanwhile, what we have is a Postgres compatible database that's really fast, faster than what you could get if you deployed it on EC2 or even used RDS. So it's a really good thing. So you talk about storage auto scaling. The Aurora, like we talked about earlier, the Aurora cluster volumes automatically grow as the amount of data in the database increases. So you don't have to worry about if you take on maybe you got a new client, you're going to take on a big load of data. You don't have to worry about how you're going to allocate that storage. You just start using it, and Aurora will allocate it for you. So that's a really nice feature. I guess you don't have to worry about paying your storage admin anymore. Next, we have automatic, continuous, incremental backups and point-in-time restore. So Aurora backups are continuous and incremental, which allows them the ability to restore to any point within the backup retention period, which is configurable up to 35 days. So if you needed to restore to 2 p.m. yesterday, no problem. Aurora can do that. If you need to restore to midnight 34 days ago, no problem. You go to the restore to wizard and you pick that time and it'll restore right back to that point. Of course, if you need something older than that, you can take manual snapshots. They're stored in S3. So your backup situation is highly secure and durable. And so it's always going to be there when you need it. Now, the great thing about that is that it's really easy to test the validity of your backups. Anybody who's ever had to restore in an emergency and found out that your backup was corrupt or the tape drives were no good, or just the time it takes to get those tape backups, if they're stored off site or whatever, that's a nightmare that no one should ever have to live through, but I'm sure many of us actually have. In this case, all you need to do is spin up another Aurora instance, restore from that backup, and you can test it and make sure that everything is exactly how it should be and it's working. And in the event of an actual disaster, you're prepared. So you can do your run books and playbooks in that regard. The Aurora also offers resource level permissions, so you can use IAM policies to control who can perform what actions on the database, which is not to be confused with your traditional database RBAC permissions, where grant permission to user type thing in the database. This is really more of an administrative Aurora level. Things like creating a snapshot, modifying a parameter group, scaling in or out. All these things can be handled through Amazon's IAM roles and groups and policies. So everything you know about Amazon today and that user administration permissions layer applies here. So you can really put a tight grip on who can do what with your database, which is probably a good thing. Probably the coolest feature that we haven't talked about yet is this fast database cloning. You can stand up a new cluster cloned from an existing cluster without actually copying the data. So it's more or less instantaneous, I guess, whatever time it takes to spin up the compute power. But it doesn't actually copy the data, which is really cool. It uses what they call a copy on write protocol, which means that only changed data allocates new storage. So really only the diff between the clone and the master are stored. So both databases can actually take writes and updates and modifications without impacting the other one. So if you were to copy your production database or clone your production database, production can still work fine. Everything, you can do whatever you need to do with production. Customers can still interact with it. You can still take and process orders and all that. But if you had a user on a clone, they can start doing all sorts of crazy things like modifying parameter groups in the database or dropping tables outright or testing indexes, a lot of different things you can do without actually impacting the production database. So I guess I just hinted at a couple of uses for that, but another possible use is maybe you've got a really heavy workload, a big analytic query that you need to run, and you don't want to impact the production database. You could use a clone to do that sort of analysis. Of course, you could also use one of the read replicas if you had one of those stood up. So maybe it's not the greatest case for that, but it's definitely a viable use case. But I think probably the most useful one, at least in my world or my experience, would be to create a copy of your production database down into a lower environment, for testing or load testing in particular. Although if you've ever experienced a bug, in with the database and the data in the database, and you try and write a fix to deal with that data, but the problematic data doesn't exist in your data subset in the lower environments, it can be really hard to test that fix. So this goes a long way towards solving that problem. Gives you an exact copy of what's in production at essentially, more or less immediate response without waiting for the request for your DBA to copy that data, export the database, re-import it, stand up a new instance. It all happens more or less instantaneously. And if you decide you make a mistake, you need to blow it away, just reclone the thing. You can all do it in a matter of minutes. So that's really cool. Again, you see pay for only for what you use, like all RDSs, and we just talked about, you're only paying for the provision compute. Although I do want to mention that there's another thing that's relatively new called Aurora Serverless. And it's auto scaling for Aurora. If you've spent any time in Amazon, you know that Lambdas are a big topic, and serverless technologies are a big topic because it gets you away from the world of provisioning hardware, and it really gets you closer to just paying for exactly what it is you're using. So with regular Aurora, you have to provision your compute like we talked about, which you might not actually use if you over provision your compute, or if you under provision, might not be enough for a surge, or you may end up with frustrated users experiencing waits, things like that. With Aurora Serverless, you're really only going to pay for what you use. No upfront compute provisioning. You just define a minimum and maximum in terms of capacity units, and really you can just think memory for that. And it drives Aurora's auto scaling rules. So as you consume more of those capacity units, it basically loads in additional compute power. It has behind the scenes, it has warm nodes ready to add into your cluster, and that's exactly what it does when those auto scaling rules are triggered. It happens on the fly. You don't have to do anything to do it. The system detects the surge in needed capacity and adds it in. Like I said, it happens on the fly. You don't lose any transactions. It actually queues them up at a load balancer layer ahead of the database, and really only see a blip in latency while it queues those in-flight transactions as that new capacity is being added. And I watched a webinar a couple weeks ago where it looked like it took less than a second to add that extra capacity. So your users were, very minorly impacted, but only for a brief moment, and then everything resumes to normal, and you've got an increase in capacity. Of course, all the other stuff we talked about with Aurora is still in play, just the addition to that auto scaling and the lack of needing to provision the compute up front. So that is Aurora, Postgres, and MySQL in a quote-unquote nutshell. So let's talk about by the numbers. So what we got is they've increased the storage limit. It used to be 64 terabytes was the max, and here recently they brought that up to 128 terabytes maximum. So contrast that with the cost of a storage array in your data center. 128 terabytes a month comes out to about $12K a month versus your $1 million storage array, which you have to buy for the capacity you might not need for years. Again, Aurora, you're only going to pay for the storage capacity that you're actually using. So if you were full on 128 terabytes, you're looking at $12K a month. But you would have to buy that entire storage array, even if you didn't need all 128 terabytes. Also, the ability to scale up. You start off with a minimum 10 gigabyte storage and go all the way to 128 terabytes. That scales with use. No downtime or maintenance is required. And that 10 gigabyte minimum has to do with how the storage is structured under the covers, which facilitates things like read replicas and cloning and highly available databases. We got in the lower left there, we have database recovery. We talked about Aurora replicating your data with 2 copies into 3 availability zones. So there's really 6 copies in total, and you don't have to pay for that, at least explicitly. I guess it's baked into the actual Aurora cost. But you can survive an entire AutoZone outage without any interruption, degradation of performance, or data loss. So try and replicate that in your data center. I wish you the best of luck. And then there in the lower right there, we have the ability to share snapshots. Easy for me to say. The database snapshots can be shared with up to 20 AWS accounts. So you can take a snap of your database, which is essentially a backup, and you can share it with 20 accounts, although you can actually do more than that if you just put in a request to Amazon. So why might you want to do that? Well, I'm glad you asked. One thing is the separation of environments. If you have dev, test, and prod, they might be in different accounts. You can share those snapshots with different accounts within your own organization. Maybe you've got a partner who you need to share that data with. You can take a snap and share it with them. And then maybe you've got a research project where you've done a bunch of work and you've got a database that's in essentially a final state for your research, but maybe other people want to piggyback on what you've done and use your work as a starting point. You could share that snapshot with other researchers and let them carry on with your fine work. So that's really Postgres there in a nutshell. I guess it's time for a poll.
Yes, excellent. Thank you so much, Craig. So I've just launched a poll on your screen. What you'll see is where are you in your Aurora lifecycle? And this certainly helps kind of drive some of the content as we move forward. But have you already started considering Aurora? Are you currently using it? Some of your databases are on Aurora, some aren't. Or are you just a 100% Aurora house at this point? We'll give just a few seconds here to let the answers roll in, and then we'll start dissecting. All right, Craig. So the early results that we're seeing, a little bit more on some databases utilize Aurora. But nobody has gone 100% Aurora yet. Based on what you're seeing on the poll results, what are your thoughts?
I think I would have been surprised if anyone was using close to 100% Aurora. I think it's relatively new, and I think there's probably a little bit of a fear of adoption of a new thing. Like the old saying goes, no one ever got fired for picking IBM. Sometimes cutting edge is just a little too risky for some organizations, and that's fair. But I think with the feature set that's is getting added, monthly, I think you're going to see more and more people using it, especially people moving away from EC2 deployments. And really, there's not a lot of reason to use Postgres RDS with Aurora on the table. But I'm sure there's some gotchas. But I would definitely expect to see most people, transitioning into that C bucket, utilizing Aurora for at least part of their workload. Perfect. And hopefully anyone who hasn't considered it before will change their answer at the end of this webinar.
Yeah, absolutely. All right, Craig, if you could jump in and quickly walk through a couple of real world examples.
Sure. So turns out there's actually people using Aurora in the real world. First up, we have the Sierra Club, which you probably heard of. So they had a public-facing online advocacy platform, but they really lacked the flexibility to manipulate that environment due to some design choices and the management structure. So the challenge was that they had a third-party managed services provider who was responsible for all the AWS services. It actually lived in that provider's account. So Sierra Club didn't really own those resources per se. So they had a lack of visibility, access, and no control over the environment, which made troubleshooting hard, things like that. Um, and then they had performance issues with the environment, and there was some challenges with scaling the MySQL database that they really didn't own or have access to. So the solution was that ClearScale built out a brand new architecture in Sierra Club's own AWS account, so they were able to really take ownership of those resources. We migrated the databases to Aurora MySQL using the database migration service, which is a really cool tool we didn't even talk about today. And we leveraged some other AWS services such as CloudWatch to help their leaders monitor things like resource usage and really gain visibility into the performance of the system. That was essentially what the problem they had in the first place. They didn't know what was going on, or they couldn't see what was going on. So we solved that for them. And as a result, they gained control over their online platform. By migrating to Aurora, they gain the ability to scale that database more or less at will, as we talked about. And the whole thing is much more agile due to the AWS infrastructure. So it really helped them solve a number of their cloud-based problems or infrastructure problems with a healthy migration that involved Aurora Postgres. So that was fun. Next up, a client called Entropics. So they're a computer vision software company. They use AWS services to reconstruct video and other images to a higher effective resolution, which they use to improve the accuracy of computer vision applications. So they've got a pretty cool thing. Now, the challenge was that they wanted to deploy a new on-demand SaaS architecture for their video processing engine. The existing system was Postgres on EC2, which meant a lot of virtual machine administration, effort for backups. Scaling was non-trivial. The whole thing really required effort and manpower to scale and maintain. And of course, they had limited visibility on their database side, thanks to the non-cloud native database deployment. And the team itself had limited experience with AWS. So they had a couple obstacles to overcome. Now, the solution was that ClearScale refactored some layers of that application into auto-scaling groups using the Elastic Container Service. So we really Dockerized the thing. They decoupled layers of the application using Amazon Simple Queue service. And then we're able to dynamically auto-scale that application by monitoring the queue depth. So simply put, more messages in the queue meant the app would scale, and as the messages cleared out of the queue were processed out of the queue, then the Elastic Container Service would scale down the number of containers that were running. So that's a really cool thing. They also transitioned their storage from Elastic Block Store to S3, which isn't always a perfect solution, but in this case, it was a great fit. S3 is a lot cheaper, it scales easily with demand, and it's highly available and durable right out of the box. And so for their use case, getting off EBS and moving to S3 was the perfect choice. And lastly, we migrated from EC2-based Postgres to Aurora Postgres. So we took advantage of all the stuff we talked about, including multi-AZ configuration to facilitate some better disaster recovery capabilities. And then management tasks such as backups and patching, became largely AWS responsibilities. So really took a lot of that responsibility off their people and put it back on Amazon. And then the results of the new architecture was built to scale along with demand, and their capabilities are now open to a much larger base of customers, and they can spend more time on their core business and less time on their infrastructure. So let's talk about migrations real fast. Really, there's three phases in any cloud migration. There's the readiness assessment, there's the planning, and then the actual execution. So as far as the migration readiness assessment goes, you might ask, well, I already know I want to move to the cloud. Why do I need to assess my readiness? I'm pretty sure I am ready, at least emotionally. Well, the process is really more of to help us understand, where you are, where your organization is in your cloud journey. It's usually a one-day engagement or so where we, establish gaps in capability and determine the overall readiness of the organization to actually do a cloud migration from a technology standpoint and, frankly, sometimes from a personnel standpoint. Next, we move into the migration planning phase, which can take 4 or more weeks. It's where we establish the business case for moving workloads to AWS. The output is something you can bring to your leadership to allow them to make an educated decision on is this something we want to move forward with. We also make decisions: are we going to do a lift and shift, or we're looking at a total cloud native overhaul, or something in between. We're going to develop total cost of ownership models and ROI forecasts, and even maybe do a pilot migration of 1 or 2 applications just to sort of get a feel for how this thing is going to go. And then we'll establish the overall readiness to do the cloud migration at scale. And then lastly, the migration execution, which can take 6 or more weeks, really depends on what it is you're trying to achieve. This is where the large scale migration actually takes place. Beyond that, we're going to look at maybe optimizations around applications and processes to really make that migration successful. The whole thing is probably not quite as simple as a few colored squares on a slide, but the thing to remember is that ClearScale is here to work with you every step of the way. You'll be leveraging our expertise in this arena to hopefully make your migration successful. So with that.
Excellent. Yes, let's get to a couple of the questions. And Craig, I know we are very tight on time, and we're going to run a little bit over, but I do want to answer a couple of questions for our crowd here. After the database is migrated, what do you do then to optimize and modernize?
Well, that's a loaded question, if ever there was one. I would say once you've got that, the database stack tackled, I guess probably look at the application layer next. Maybe look at elasticity and availability, auto scaling, multi-zone availability for starters, making sure your application works at all times. Maybe look at containerization using that elastic container service like we talked about with Entropics, and then maybe using some decoupling tactics like simple queue service or Kinesis to decouple your application and eliminate those hard dependencies and isolate systems from performance bottlenecks or worse. And then maybe consider refactoring your application altogether into a serverless model using like something like API Gateway or Lambda. I think those are probably the typical tactics people use when they're modernizing their stack.
Awesome. And then how can I prepare for the migration readiness assessment phase?
It probably really comes down to documentation and preparedness, really. If you've got architecture diagrams, application documentation, infrastructure network, and anything related to that, really the more answers you can give during that assessment, then the better the assessment's going to be. Also, identify all the relevant members of your internal teams, from security, infrastructure, delivery, et cetera. Having those people identified up front is helpful. And then lastly, it sort of goes without saying, but I'll mention it here. Anyway, is you have internal alignment at this point. It's also really beneficial, making sure that everyone's sort of pointing the same direction in terms of that migration is really a good thing to have. So you're not fighting it along the way. There's enough obstacles to do a cloud migration. Hopefully your personnel won't be one of them.
Excellent. While I'd love to get through a few more questions, I do want to be cognizant of everyone's time. So since we're up against the clock at this point, should you have any questions, please feel free to schedule a consultation with our solutions architects by simply reaching out to sales@clearscale.com. We do have a few more webinars rapidly approaching, including Simplify the App Development Process with AWS Step Functions on November 12th. And then a couple of follow-ups to today's webinar include Getting Technical with AWS Database Migrations on November 19th and Migrating and Modernizing Mission Critical Databases on December 10th. All these invites and more will be coming out within the next couple of weeks. So please be sure to sign up for more great information. Again, special thanks to Craig Nelson and everyone for showing up today. Have a great rest of your week, and we look forward to discussing migrations with you soon. Appreciate it, everybody.